All right, so the first type of symmetry is a symmetry I think you should have recognized as y-axis symmetry. That's something that you've done many times throughout your math career. And so hopefully you notice that 4 and -4 are paired with the same output, and 2 and -2 are also paired with the same output. That's going to happen when you have y-axis symmetry. And so over to the side, I want you to write some notation that you probably haven't seen before. When there's y-axis symmetry, f of -x is equal to f of x. They have the exact same value. When they're opposites, you get the same output. Now that's a special type of function that's called an even function. So I'm just going to jot that down, and we'll talk more about that on the other side with our notes. Now don't get that confused with an even degree function. Now in Algebra 2, you talked about even degree and odd degree. This is not the same thing. So an even function is a special function that has this y-axis symmetry. All right, and then if you just have the equation, you could try plugging in opposites and making sure you always get the same result. How did you describe the symmetry on number 5? Did anybody? It's actually not x-axis symmetry. So x-axis symmetry would be like if you folded it on the x-axis, it would fold on top of itself. And that doesn't necessarily happen. You would get something like that. It's kind of x and y-ish. This is actually called origin symmetry. And that's a brand new symmetry that I don't think that you guys have ever learned before. Now, some people say something like if you rotate it 180 degrees, it will rotate on top of itself, and that's true. 180 degree rotation. But this is origin symmetry. So I hope that you notice that 4 and -4 have opposite outputs. And same thing with 1 and -1, they have opposite outputs. So when you evaluate f of -x, or g, is this g? Let's fix that. G of -x, it doesn't equal g of x. What does it equal? Negative g of x. Very good. And that's what happens when you have an odd function. Right? And some things you could do if you had the equation, plug in opposites, make sure you get opposites if it's odd. And for her face, it's crazy symmetric. I think it's somehow proven that people who have symmetric faces are considered to be more attractive than people who have unsymmetric faces. That's why most models and actresses have symmetric faces. Okay, so let's look at the notes on the back. This is important. It's all important, but that I wanted you to kind of get a little head start on even and odd functions. So a function is even, or a function, if it has y-axis symmetry. All right, I'm going to try to draw one. It's pretty much similar to the one that was on the other side. All right, so I'm going to pick a point up here. I'm going to call it xy. If this is an even function or has y-axis symmetry, and that point was xy, what should this point be over here? Negative xy, good. All right, and then let's go ahead and rewrite that. F of -x equals f of x for y-axis symmetry and for even functions. All right. And then all odd functions are going to have origin symmetry. So you can draw a swishy one like the one on the other side, or I'm going to draw one that's a little less complicated. All right. And so in this one, I have the point xy. So if this was an odd function, what would this point be? Negative x, negative y. Very good. And so in this case, f of negative x is equal to the negative f of x. Right. So sometimes you're gonna have all different types of questions. So sometimes you're just going to say, if this point is on an even function, what other point would be on an even function, or odd? Or it might give you half of a graph and you graph the other half. But sometimes it asks you to prove that a function is even, odd, or neither. And when you have to do that, algebraically, what you do is you plug in negative x and then simplify it down, which wouldn't be very difficult to simplify, and then compare it to the original. So if it is the exact same as the original, what do you think that means? Even, odd, or neither? It's exactly the same as the original. Even. That is even. That is this right here. F of negative x matches up exactly with f of x. So if it's the same, then it's even. Right. Then if you plug it in and all signs change, which means it's exactly the opposite of the original, then it's going to be odd. All right, and then I didn't give myself a lot of room. I'm going to write it slanted. So, and then if some signs change and some don't, then that's going to be neither. And a whole lot of functions are neither. An infinite number, actually. An infinite number of all are even and odd. But don't be surprised if it's neither. It's fine. Even and odd are special functions. Okay, so let's do some examples. So in the first example, we have half of it odd function is sketched. We want to sketch the other half. So I'm just going to take this one point at a time. So I'm going to start with this point, this dark blue point. That's the point 3, 0. If it's an odd function, you should change both of those signs, except 0 doesn't have a sign. So that's going to translate to negative 3, 0. Okay, and then we have kind of like a quarter circle, and then the next point exactly we have is 3. I think I might have said those other ones wrong. This one was, this was 0, 3. That goes to 0, negative 3. This one is 3, 0. And so it should go to negative 3, 0. Okay, and then we have 5, negative 1. Which should that be for the odd? 5, negative 1? Negative 5, positive 1. So if it's odd, you're going to change both signs. Right. And then the last one I see is 7, negative 2. So that should go to negative 7, positive 2. Okay. And then try your best to draw a quarter circle. It's harder than you think. And then a line segment. So that's the other half of the graph. And they don't have to touch each other. It's fine. They don't. It's still a function. All right. Any questions on that? Okay. So let's look at number 2. So if the point 3, negative 18 is on the graph of an even function, what other point is guaranteed to be on the graph? Negative 3, negative 18. Very good. Because that's what happens on odd functions. So even functions, opposites are paired with the exact same number. On odd functions, they're paired with opposite numbers. All right. And then for number 3, we have G. We want to know if G is even, odd, or neither. And they ask us to prove algebraically. So we do have to show some work here. So to prove algebraically is when you put negative x in for x. So that's not too difficult. You just go back and you change all the x's to negative x's. And then what do you get if you have a negative raised to an odd? Is that going to be a positive or is that going to be a negative? A negative. So a negative times itself 3 times or 5 times is going to give you a negative. And then same thing here. A negative x to the third is going to be a negative x to the third. And then since 3 is a constant, it doesn't change. It stays just like it is because it doesn't have an x. So what you guys say? Even, odd, or neither? Did all the signs change? All of them? The 3 didn't. So this is one that's neither. So some signs changed, some signs didn't. And to finish up the answer, I would say that g of negative x doesn't equal g of x and doesn't equal the opposite of g of x. So that's the case when it's neither. All right, and then for number 4, this is going to be true or false, and you have to do more than just say true or false. So if it's true, explain why it's true using the definitions. And then for false, you just have to provide one counterexample. And so A says that all even functions go through the origin. Do you think that has to be true for even? It doesn't. The one I drew up here, even function, doesn't go through the origin. This one is basically the same function. So this is false. And you can just do a drawing or you could write an equation. It's up to you. It's a little bit easier just to do a little graph. All right, and then for B, if a term is in a polynomial, if each term in a polynomial function has an even exponent, the function is even. What do you think? Can you think of a counterexample? Yeah, this is true. Because raising negative x to an even exponent results in a positive. So f of negative x would equal f of x. Be careful. Is that true for odd? If all the exponents are odd, is it going to be an odd function? No, because we have a counterexample right here. All of these exponents were odd, but we had that constant, and that constant's not going to change, so that's going to be neither. So Just be careful when you do it that way. All right. What questions do you guys have? Well, because on an even, you don't want it to change. So on an even function, constants are perfectly fine. Did I answer the question you asked? Okay. All constant, if it's just a constant function, that would be an even function. Because like if you just say like y equals 7, up at 7, that would be a horizontal line, which has y-axis symmetry. So they're all even. All right. Any other questions?